Demystifying Evals for AI agents. This is a new blog post that was published by Anthropic, and I really love reading the blog posts that are published by the big labs. Usually they are very educational and written well, and specifically I like what Anthropic is publishing because I consider them being in the frontier, and if they are implementing best practices or they are driving or they have ideas or notions regarding how we should build and automate, I usually take inspiration from what they are doing. So I want to discuss today this blog post about demystifying evals, which based on my experience, many people consider to be a non-important or non-sexy topic. It also shows in my videos that are specific about evals. Usually when I upload a video about evals, it's mostly crickets, no viewers, maybe just a few. And if I upload a video about a new Cloud Code skill or stuff like this, I see that the viewership and the excitement is way more significant, which makes sense. But if you're asking me in terms of impact and importance, I think evals are way more important than 80 or 90% of the stuff around there. And why are they so important? Because evals is the only way for a builder to actually validate what his agent is doing. So this is why evals are so important. I will go very fast over this blog, just highlighted the most important stuff because I wanna make sure that you guys are informed. If you're interested in learning more about evals, I have a few more videos about evals in the channel, and I will also drop the link to the blog post in the video description. Okay, let's get going. I created a Chrome extension that basically highlights websites for me. So let's get going. Good evaluations help teams ship AI agents more confidently. Without them, it's easy to get stuck in reactive loops, catching issues only in production when something failed, when a client complains or stuff like this. And evals makes the whole testing of agents way more predictable because you actually know what your agent is producing. Now, it's very easy. It's easier to build evals for single turn conversation, which basically means we have a prompt, the LLM is going to respond, and we can grade the response. On the other hand, evals for agents are a bit more complex because there are more moving parts in the conversation, more moving parts that we need to actually grade or evaluate. So as it says here, for a more complex multi-turn eval, a coding agent receives tools, it gets a task, it connects to an MCP, etc., etc. There's a whole agentic loop which consists of many moving parts, and this is slightly harder to evaluate. This is why it's so, on one hand, I guess overlooked, but on the other hand, this is so important because one of the things that I see often, people decide not to build agent because they are under the notion that agents are not reliable or they don't work in production. This is true in 99% of the time when you don't do testing. I can say the same regarding code in general. If you write code and you don't write unit test, end-to-end test, integration testing, etc., so the code isn't reliable on the same token. So basically, it's kind of funny to say that agents are not reliable if you don't have any means of measuring them. So some like jargon regarding evals. First, we have a task, which is basically the problem or the test case that we defined and we expect the agent to solve. Then we have the trial, which is basically an attempt to solve the task. Then we have the grader, which is the logic of how we are going to score the trial. We have the transcript, which is often called a trace or a trajectory, which is basically the whole conversation going back and forth. And we have the outcome, which is the final state in the environment. For example, A flight booking agent might say your flight has been booked at the end of the transcript, at the end of the conversation, but the outcome is whether a reservation exists in the environment SQL database. So it's one thing that the agent can claim, but on the other hand, there is a deterministic way to measure, in this instance, whether the task was executed and the trial succeeded or failed. Okay, so these are like the components of an evaluation: the task, the graders, and the agent harness, which we didn't discuss, which is basically the infrastructure. Now, why build evaluations? I guess it's kind of straightforward. You want to be able to measure what you're doing. As Peter Drucker said, what gets measured gets managed. If you don't build evaluations, there are many downsides actually to not building evaluations, and let's cover them. First of all, many people start building an agent, and when they want to push in production, things start to fail and things start to break, and it obviously happens to me. So I'm speaking from like first-hand experience, and this is why you must have the evals before, because you're kind of setting benchmarks for your agent. They say the breaking point often comes when user reports the agent feels worse after changes and the team is flying blind with no way to verify except to guess and check. Absent evals, debugging is reactive. You wait for complaints, you reproduce manually, you fix the bugs and hope nothing else regressed. The teams cannot distinguish real regression from noise, automatically test changes against hundreds of scenarios before shipping or measure improvements. So basically, let's imagine that we have an AI agent. We are operating on Opus 4.5, which is by far the leading model at the moment. 3 months' time, Anthropic are going to ship a new Opus 4.9, for example. You are going to switch. You are going to start working with 4.9 under the impression that it is working better. Suddenly, you get a flood of complaints, or you go to Posthog or Sentry and you see a ton of errors, stuff like this. And you're not sure what to assume. You're saying, okay, Opus 4.9 is the only change that I made recently, but it's supposed to be superior. It's supposed to be better than 4.5. So what's going on? What happened? And now, because you didn't establish a baseline, you don't know what was the performance for the 4.5, the recent model. You cannot really analyze and understand if something broke regardless of you switching to 4.9, or was it because you switched to 4.9, and specifically what broke. There are many moving parts. As we said, let's say a customer support agent, he might start speaking in a non-polite manner to customers. So customers might be complaining about that, but on the other hand, he might be solving tickets faster. So what's going on? It makes everything very obscured. So they say writing evals is useful at any stage in any agent lifecycle. Early on, evals force product teams to specify what success means for the agent, which is a huge benefit. It's kind of like test-driven development. First, you understand what you expect from the agent, and based on this, you build the evals, like the test, to see what the agent is producing, and only afterwards you start building the actual agent. Okay, we discussed this. Okay, this is kind of an elaboration. So once eval exists, you get baselines and regression tests for free. So you can analyze the latency, you can analyze the token usage, cost per task, error rate, etc., etc. Now, how to evaluate agents? Basically, there are 3 types of graders. Code-based graders, which is more, I'd say, more deterministic. We have model-based graders, which is also called LLM as a judges, and we have the humans. Now here's like the pros and cons of each method. So code-based, more deterministic. You can verify stuff, more like pass-fail. The strengths are obviously they are fast, they are cheap, objective, reproducible, easy to debug. And the weaknesses, they are brittle, they lack nuance, and they are limited for evaluating some more subjective tasks. On the other hand, LM as a judge is more rubric-based scoring. It's more subjective. It can make assertion based on natural language. You can create multiple judges. It's more flexible. It's more scalable. It understands nuance, but it is not deterministic. It is more expensive, and it requires a lot of calibration with human graders for accuracy. What does that mean? Let's say I wanna, again, regarding the previous examples that we said, let's say I wanna grade the politeness of my customer support agent. So it's not deterministic. It's not as if I can use the code grading agent and see how many times it said thank you or how many times it said please, and based on this derive if it was polite or not. It's a subjective measure or that contains many subtle nuances. Now, we can use an LLM as a judge to do this, but how are we going to calibrate the politeness? We need a human to take a look at the traces or transcripts and provide feedback to the LLM as a judge and basically adjust the prompt and adjust the guidance to the LLM as a judge until he performs based on how we would like him to perform. And we also want to make sure that the grade that the LLM as a judge is providing is kind of similar to what grade we would have given to a human being which was conducting the same judgment. So we want to align the scoring with what we believe is a good way to score. Now, human graders obviously produce golden standard quality. It matches expert judgment. It is used to calibrate model-based graders. It is expensive, slow, non-efficient, etc., etc. Now, for each task, and this is very, very interesting and many people overlook this, you probably need to have all three of them, combine them in some weighted average. So you combine the code-based graders with the model-based graders with the human-based graders. Now let's discuss two types of evals. First of all is a capability or quality eval, which basically asks, what can this agent do well? On the other hand, we have regression evals, which basically ask, does the agent still handle all the tasks it used to do? So this is more if we have already an established agent and it is already working well with the current prompt and it's producing high scores in the evals, but now we suddenly change something in the prompt or in the model, we want to have a regression eval and see that basically the quality doesn't backslide, as I mentioned here. As a declining score signal that something is broken and needs to be improved. Moving forward, coding agent, did we discuss this? Okay. Don't want to discuss this. Okay, so this is a bit more nuances regarding different type of agents. So you have an coding agent which you can analyze, which is slightly more easy because it's usually more deterministic. You have a research agent which is slightly more subjective because what is a good research? It depends on many aspects. It depends on context. So they share that one strategy to build research agent evals is to combine grader types. So check groundedness to verify that the claims are supported by retrieved sources. You have coverage checks that define key facts a good answer must include, and source quality, which checks and confirms the consulted source or authoritative rather than simply the first retrieved. So this is like nuances for building a research agent or eval for research agent. And we have also computer use agents, which is basically an agent that is supposed to be able to browse your computer, conduct actions on behalf of you, and there are established benchmarks for this, such as Web Arena and OS World. Now, how to think about non-determinism in evaluations for agents? Regardless of agent type, agent behavior varies between runs, which make evaluation results harder to analyze. Each task has its own success rate, maybe 90% on one task and 50% on another, and a task that passed on one eval might fail on the next because agents are powered by LLMs. LLM are non-deterministic by nature. So one thing that is working now might not work in 5 minutes time. So there are two metrics that we usually use in order to analyze this. So first of all is pass at K, which measures the likelihood that an agent gets at least one correct solution in K attempts. As K increases, pass at K score rises, which means more shots on goal means higher odds of at least one success. A score of 50% pass at 1 means that the model succeeds at half the task in the eval on its first try. Now we also have this, which basically measures the probability that all K trials succeed. As K increases, this basically falls since demanding consistency across more trials is a harder bar to clear. So for example, if your agent has a 75% per trial success rate and run 3 trials, the probability of passing all 3 is 0.75 at the power of 3, which is approximately 42%. So this is like a graph that shows the differences. Now over here they discuss how to go about in building evals. I discuss this in more detail in other videos of mine, but basically you want to start as early as possible. You want to figure out what is the ground truth, what is important for you, and how does a good case look like. Then you write unambiguous tasks to test it. You write how does it look like when it fails, how does it look like when it succeeds. Then you write a prompt. Then you start analyzing the results that the agent produced, and you can annotate them based on different parameters. So categorize them, provide free-form feedback, whatever. And after aggregating the categories or all the feedback that you basically, let me think if I can explain this better. Okay, so let's assume that I have a customer support agent. So I start analyzing traces and I see one response wasn't polite. The other one asked too many questions. The third one was providing non-relevant data. So I can start writing down next to each response of the agent what I didn't like about it. After I did this, I can categorize all the type of feedback that I gave. So one is politeness, then is lack of accuracy. Third one is misguiding question, etc., etc. You can also use ChatGPT in order to categorize your feedback. And based on these categories, you start defining evals. So one eval is accuracy eval, the second one is ambiguity eval, the third one is accuracy eval, etc., etc. And then you can start analyzing. You build LLM as a judges to judge the responses of your agent. You analyze the response of your judge to see whether or not it's a good response, or if the score that you would have provided aligns with what the agent or the judge provided. And based on this, you decide, first of all, how to reiterate or optimize the prompt for the agent and how to adjust the LLM as a judge so it will align better with what you as a human judge see and believe should be accurate and true. And I know it might sound more complex than it really is, but it's pretty simple. So you start early. You start with some manual tests. You write unambiguous tasks. You cover positive and negative cases. You build the robust eval harness, which basically, as I said, is also grading or verification, non-LLM. and also you create graders with LLM. You check the trajectories, basically the conversation. You monitor if anything changes after like a few instances. You see if the LLM as judge is producing good results, and from there on, it's basically moving to maintenance mode, which basically you have the evals. You need to decide whether or not you want to add a new eval. You need to decide whether or not something in the eval isn't accurate, and you need to adjust the eval. So it's a constant, it's a continuous process. Let's see an overview of approaches for understanding AI agent performance. So first of all, we said we have automated tests. Then we have production monitoring, which is not exactly automated evals, and there is a big distinction because here we are using kind of LLM as a judges. Here we are more tracking metrics and errors in live systems. So I use Postdoc to see like session recordings and see rage clicks that a customer has in the website, or see any errors that the customer has. This is more reactive, but it's also based on what users are actually encountering now in your website, in your web app. On the other hand, the signals can be noisy, and obviously it requires setting up the infrastructure for monitoring. Then they mentioned A/B testing, which I'm not sure I want to go into this because it's not so, it's a slightly more advanced. We have the user feedback, which is also something that is relevant for the LLM as a judges and the whole monitoring process, because we can ask users to provide a thumbs up or thumbs down, which also gives us somewhat of clarity regarding how good is our agent performing. We have the manual transcript review, which I mentioned, and we have also systematic human studies, which is basically a more structured way of actually grading the agents, which trained raters, which I think most of the people probably won't do this unless you're like with a lot of funding or have like a big research lab. Now these methods, all these methods, they differ they have pros and cons, and they should be used in different aspects of development and in a different magnitude. But the whole idea is actually having somewhat of a Swiss cheese for this, because you have the automated evals, you have the manual transcript review, and you have the production monitoring, and each one is solving something else. Now they're saying the most effective teams combine these methods: automated evals for fast iteration, production monitoring for ground truth, and periodic human reviews for calibration. So this is the conclusion. Basically, this whole video, it was a bit long-winded, to be honest, but I think it's a very important topic, so this is why I wanted to record it. Don't overlook evals. If you're building agent, try to set evals at least something as soon as possible. You must have capability to read the traces, so add lang views, add whichever observability solutions that you would like, just so you know what's going on under the hood. And as soon as possible, start implementing even simple evals, whether it's LLM as a judges, or if it's like monitoring the input, making sure that there are no prompt injections, monitoring the output, just with if conditions. Anything is better than nothing. So I want to encourage you to start thinking about AI agents not as something that isn't reliable in production, but as something that can be reliable. Obviously, it's a spectrum. It cannot be 100% reliable because it's a non-deterministic process, but you can increase reliability if you inject the right evals into the process. Let me think. Yeah, I covered everything that I wanted. That's it for today, guys. I hope you enjoyed this video. Obviously, like and subscribe. Leave your comments below if you have any other good resources for evals. And until next time, keep on automating.